Hi, my name is Chelsea. This is crown ether synthesis with applications in metal selectivity. So just a brief background, fluorophores is the main component of this project, and they are fluorescent chemical compounds that re-emit light upon light excitation. Fluorophores have something called a fluorescent lifetime, and that is the change in its energy state of its electrons. As the electrons are returning to a lower energy state or their ground state, they are re-emitting that light energy that was absorbed at a longer wavelength, and that corresponds to the color that we see. We hypothesize that our chemosensor we're synthesizing, is going to have a selectivity and it's going to be able to have a great read. So the methods and instrumentation used is UV-Vis and spectrophotometer. UV-Vis is mainly used to determine the mechanism that we're having and also the wavelength needed for the spectrophotometer. And the spectrophotometer just determines the intensity of each trial and the fluorescence. So the idea of this project came from some previous work done in Dr. Foss's lab where they tested for the detection of barium-2+ in both the wet and dry phase. And what they did is that they used 3 different crown ethers and 2 different fluorophores, and with the result, 18 crown 6 ether anthracene had the best overall response. And because of that, we are going to use 18 crown 6 for our bonding with our fluorophore. And the fluorophore that we are going to use is 9-bromofluorine to create N-methylfluorine monoazo crown ether. So here, as we zoom in, we can see that the mechanism here that's going on is PET. And PET is photoelectron transfer. The reason why we know that it's PET is because there is a consistent peak at this wavelength here. And if there wasn't a consistent, meaning if there was some type of shift, then we know that there's ICT. But because there's no shift, we know that the mechanism is PET. So for our results, here is just the different concentrations in which we tested our fluorophore on its own, and with that we were able to get the data needed to create this graph. This graph here just gives us an idea of the optimal concentration that we need for our metal samples. And what we're looking for is that we're looking for the concentration with the steepest peak. And the reason why we didn't do 10 is because 10 had a very low reading, so therefore we went to the next best thing, and that was 20 microliters. So here is the different metals and its response, its fluorescent response. As we can see that the fluorophore was selective to all the metals. It's not quite what we wanted, but it shows that it reacted with all of them. And here just shows what was another thing that was going on that was interesting, was that there was some overlay between the fluorophores, and because of that, it caused this second peak here. It caused a second reading, and we just thought that was interesting. So for our conclusion, every metal that was tested had a positive reading, and that resulted in a poor chemosensor. And we want our chemosensors to be efficient, meaning we want it to have one selectivity to one metal, and we want it to be zero response with others. That is useful because it allows us to be able to look at an unknown sample, get a positive reading, and know exactly what metal is present. So for our future work, we want to test another group of metals. We also want to go as far as doing a solvent and pH study. And if these new conditions result in positive findings, we want to go as far as determining the limit of detection. This will help us figure out how little amount of metal needs to be present in order to get a reading. Is there a certain concentration that we need, and what is that number? And it also allows us to create a calibration curve. That curve can be used to find unknown concentration once we know what this chemosensor is selective to. So lastly, I just want to give the acknowledgements to Dr. Foss, Dr. Shug, Dr. Wicker, and the graduate students that helped me, and ACT program for giving us an environment to just conduct research and present new findings. And here's our references. Thank you so much for your time.